Welcome back. In this video, I'm going to show you how to run a topic model using Python. So here, all I've done is I've set up a folder that contains a couple demonstration corpora. So if we look inside my Anaconda prompt and I just see what's there, you'll see that I have a demo corpus and I have a folder called fed papers. So these are the two corpora that I'm going to show you how to topic model. If we go inside the demo corpus folder, just like this, and I take a look at what's in there, we can see that I have all of these square boxes because I haven't set up my Anaconda prompt here to properly show me Chinese characters. To do this, all I need to do is to go into Properties, and I need to select a font that actually displays Chinese. So if I click on Font, we can choose a font that is capable of showing us Chinese characters. So one option is Fang Song. Okay, so what I can do now is I'll also show you the fed corpus. And you can see that this contains all of the Federalist papers. And it's actually labeled by the author of each one because I've also used this corpus as a demonstration for stylometry and detecting authorship. But let's get started. I'm going to back out of this. And I'm just going to clear my console, and let's start writing a little bit of Python code. We should always start by adding a doc string at the top of our file that describes exactly what it is going to do. So this script will run a topic model for us. This is pretty basic. You would generally want to be a little more specific than this, but for the sake of this demonstration, that's what I'm going to do. And I'm just going to call this tm.py. Okay? And so now Visual Studio Code recognizes this as Python. The next step is to import the libraries we're going to use. So here we can import gensim, which is the library that actually runs the model for us. I'll go ahead and import NLTK, which I'm going to use to tokenize the English corpus. And I'm also going to need to use the OS library to load in this corpus. Now, generally when I do this, I like to create an object that lets me filter the files so I don't analyze files that aren't useful for my purposes. So for example, if I'm on a Macintosh, I might want to ignore my DS store file. So here I'm going to create an object that filters files I want to ignore. And I'm just going to call this ignore files. And this will be a set. And I'll just say ds store, for example, and .txt because there is actually a hidden file in my corpus called .txt. I kind of just want to ignore that. So the next step is to create a couple variables that will hold our corpus. So contains input corpus. And I'm going to have a list that is just my texts. Like that, and I'll have something that I'll call labels that will hold on to the titles of these files. Now, like we've done in a bunch of my other videos, I'm going to use the OS library to load these files in. So iterate through all files in the corpus folder. So what I'll do is I'll say for root dirs files in os.walk, and let's start with the fed papers. So now all I want to do is I want to go through each of these files and open them up and save them into my current namespace. So to do this, I'll say for file name in files. Then what I want to do is I want to check whether or not that file name is in my ignore files set. So I'll say if file name not in ignore files, then go ahead and use a context manager to open that file. Now I'll say with os.path.join to make sure that this stays platform agnostic. I'll join the root and the file name. And I'm going to call this as rf. So the next thing I want to do is I want to get the string out of the file. So I'll just say text equals rf.read. And I'm going to do it this way because I do want to tokenize this text into individual items. So I'll say tokens just equals nltk.word tokenize text. And of course, this is something we covered when we talked about the Natural Language Toolkit. Now here, optionally, I can do a few things. I might want to clean up this file to make sure that it doesn't contain things that I'm not interested in, like numbers or punctuation marks. So here I can do something like cleaned equals, I'll just say word for word in tokens, if word.isAlnum. So this will just check, is this an alphanumeric item? And if it is, go ahead and save it. Once I've done that, I can append that cleaned list of tokens to my text list. So text, append, clean. Now I could condense this into just a couple lines, but being a little more verbose is always nice because it makes it easier to follow the code if I've forgotten what I was trying to do. And of course, I should also be commenting this. Now, I also want to save information that will let me label the output. So here, I'm going to go ahead and append the file name, and I'm going to get rid of the file extension, which on all of these is .txt. I'm just going to dump that and keep track of it. Up to this point, we've not really done anything new that we haven't seen in other videos I've made on this channel. But now I want to talk about using gensim to actually do our topic modeling for us. Now, technically I'm using gensim as a wrapper for Mallet, as I mentioned in the last video, but it also has a bunch of other models that we could use for text analysis. So we're going to do that right now. So the first thing that I want to do is, because gensim is optimized to take advantage of hardware, it often wants to use integers rather than strings for its analysis. So it has some functions that make this a little bit easier. So the first thing I'm going to do is I'm going to build a dictionary for my corpus using gensim. So I'm going to transform the corpus to run in gensim. And I'm going to do this simply by saying I'm going to have a corpus dictionary. And I'm going to say gensim.corpora.dictionary. And I'm going to give it my texts. Now you can actually find a tutorial on gensim that does something pretty much exactly like this on their website, and I'll put a link to that in the description here. So now I have a dictionary that will map all of the terms in my corpus into a Corpus Dictionary object that comes from gensim. Now this dictionary object has a bunch of interesting features that will help us do our analysis and constrain it in some interesting ways. Now I don't tend to do this, but one thing I could do is I could take my Corpus Dictionary and I could filter the extremes. And I could tell it, you know, if a term doesn't occur more than 3 times, I'm not interested in using it. I could also say, if something occurs in more than half of my documents, I want to ignore it. So this is one way of kind of very quickly filtering words in an interesting way. Now, I'm not going to do that because I find that this takes out words that I'm often quite interested in. But if that's something that you're keen on doing, you're welcome to do so. So the next thing I want to do is I want to take my raw corpus and transform it into a bag of words representation. That is, just go through each document and count up how often all of the terms occur. But instead of using the string to represent the word, I'm going to use an integer that maps to that string. Okay, that's just why we made this corpus document. This corpus dictionary. Now this is simple enough. I'm just going to make a new object that I'm going to call process corpus. And what I'm going to do is I am just going to iterate through each of my texts and transform it using my corpus dictionary. To do this, I'll just say corpus dictionary, and I'm going to say doc to bag of words. I'll give it my text for text in texts. Okay? So this is simply just going through the corpus and mapping each word onto an integer and counting up how often that word occurs. Transform corpus text list into list of bags of words. Okay? Now we can actually see what this looks like simply by printing, let's say, process corpus 0. So this will print the first of our texts in this integer representation. I'll save this. I'm going to come over here to my Anaconda prompt, and I'll just say python tm.py, and it'll take a second to load in and do all of the conversions, and it'll show us what's going on. Okay, so now what it shows us here is it has an integer for each word in our corpus. So 0 would be the first word in the corpus, 1 would be the second, and so on. And then it gives us the count of those words. And this is what we are going to be running our topic model on. So what I could do is I could also take a look at this and kind of check, well, what is that first word? And I'll do this by running this again, except I'm going to run it in interactive mode with the I flag, just like this. Okay, and now what I can do is I can actually take this Corpus Dictionary and I can just check, well, what is that first word? 1787. What's the second one? 23. What's the third word? A. 3. Among. 4. Against. And so you can see it's actually in alphabetical order, interestingly enough. Okay, so we're all set, and now we can start to think about running our topic model. Now, in the other video where I talk about what a topic model is, you may recall that one of the decisions that we're going to have to make is how many topics are we looking for? And we need to tell our algorithm how many we want. So I'm going to make a variable that I'm just going to say is number of topics. And I'll move this here, and I'll just say number of topics. And we'll just start with 40. Because we're actually using gensim as a wrapper for Mallet, we need to tell it where Mallet is living. If you remember, I just put it at the root of my C drive. So here I'm going to say my Mallet Path, specify where Mallet lives. And I have to do this even though I set the path in the last episode. I need to say os.path.join, and I'm just going to say it's at C, and it is Mallet, and I need to tell it the binary and Mallet. Okay, so this is exactly where it is. Now, if you're on a Mac, this might look something a bit more like tilde, comma, Mallet, comma, bin, something like this. Okay, it depends on your own system and where you put it. So now what I want to do is I want to create the Mallet object itself. To do this, I'll say create the Mallet modeling object, and I'll say LDA model because we are using the LDA algorithm. And here I'll say gensim, models, wrappers, LDA Mallet, .LDA Mallet. And now I'm going to give it a bunch of different parameters that specify how we want it to handle the analysis. The first thing is the Mallet Path. That is where Mallet lives. The next thing is the corpus itself, and this is going to equal our processed corpus. And make sure you're putting commas between all of these different things because otherwise it won't work. We need to tell it how do the ID numbers map to words. And we use our dictionary to do that, so Corpus Dictionary. I'm going to tell it how many topics we have. This is number of topics. And I'm going to give it an optimize interval. Essentially, what this does is this allows me to tell Mallet how often should it optimize its hyperparameters. And in doing so, this will actually allow the different topics to have different weights in the end, which makes for, generally speaking, better output. Now, if you look at Mallet's documentation, it'll say something like every 10 or so intervals is a good way to do this. So I'm just going to say optimize interval at 10. And finally, I need to specify a prefix that will tell Mallet how to name the files that it's going to generate for me. So I'll say prefix, and this is going to equal, I'll just call it fed, with an underscore because it's going to add this to the start of all of the files that it creates. Oh, and I need to make sure that I have a comma here, otherwise this will fail. So what this will do is this will create our topic model and go ahead and run it for us. And technically speaking, this is all we really need to do. So if I quit this inside my terminal, and I run this again without my interactive flag, it will feed all of my texts into Mallet and run this for me. Uh-oh. Oh, I see here. You can actually see if you look at this. I'm getting this error message. This returned a non-zero exit status of 1. This means it actually isn't finding where Mallet is. And you can see here that my path is messed up because it hasn't put a backslash between C and Mallet. So that's my fault. So here, what I'll do is I'll simply say C:/Mallet. Okay? I'll save it and I'll rerun this. And now we can see that Mallet is running and it's trying to generate our topics for us. Well, it in fact is generating our topics for us. Now we can see that this has worked. But if I go into my folder where I ran my script, I should find the output files for this. So if I go in here and I go to my C drive, users, here, this is in YouTube, here, and now we can see we have all of these different files. We have fed corpus. This is actually information about the corpus itself. We have document topics, we have topic keys, and some other things that we're not going to get into. But if I open up this topic keys, we actually see all of the different topics that the topic modeling algorithm generated. The first topic, topic number 1, is military, militia, establishments, army, danger, peace, defense, and so on and so forth. This actually makes quite a bit of sense. Governor, York, king, Great Britain, parliament, treason, so on and so forth. Okay? So we can see that the output actually seems to make quite a bit of sense. And we've done all of this using really not very much code. Here we have 45 lines of code. I could really condense this quite a bit. I don't have to actually work with those files that were generated. I can still stay in Python and work with the objects that have been created. So I could say topics equal LDA model show topics. And here I could tell it number of topics. You know, maybe I'll look at all of them. So here number of topics and num words. Let's say 50 words. And then I can just go through each of these topics for topic and topics and just print it out. So now what I can do is I'll just go ahead and run this and we'll take a look at the output. Okay, and so now you can actually see that it printed out all of the topics and the first 50 words in those topics with their weight. So this is actually a pretty nice result. So how would I adjust this to work with the Chinese corpus? Well, this is actually pretty simple. All I would need to do is change this corpus over to demo corpus. And if we take a look at this, and if I just change my directories into demo corpus, and I print everything out that's here, we can actually see this is just a collection of files of mostly Ming and Qing text, some Yuan stuff. These are different types of documents. I have official histories, I have novels, I have Huaben short stories. It's a much larger corpus, but it's one that I'm actually interested in terms of my research. But to adjust this, really the only significant difference is here on line 21, where I'm creating my tokens. So here I need to switch my tokenization methodology. Now, there are a lot of ways I could approach this, but what I'm going to do is I'm going to write myself just a small little function that will tokenize this as an engram. So here at the beginning, I'm just going to define engram tokenize, and I'm going to say, you know, I have my input text and I have n. And I'm going to, by default, do n equals 1. Okay? So here, I just need to return text. We'll do something like I to I plus n, like this, for I in range length of text minus n minus 1. Okay, so this will just go through and tokenize this into overlapping engrams. And of course, I need to close this, and that's that. That's actually a pretty basic engram tokenizer. I might want to set this up so it doesn't do overlapping engrams, it does discrete ones, but this is fine for the moment. And so now, all I need to do is I need to go here on line 24, and instead of using NLTK to tokenize this, I'll just say engram tokenize text. Now everything else should work just fine. So here I'm gonna back out, and I will run this. And I will run this again. Python tm.py. But of course we're running into an encoding issue. So here I'll specify the encoding as UTF-8, which I should have done earlier. And now it should work just fine. Now, sometimes I might have to tell it how to handle errors if need be, but hopefully I won't need to deal with that here. And this might take a fair amount longer simply because it's a much larger corpus that needs to be processed. Okay, so it looks like it's loaded, and now it's going to give that data to Mallet, and it didn't like it. Why didn't it like it? Oh, and I also will want to change my prefix to something else, and I'll just call this demo. Here we can actually see that I've run into an issue where Java's run out of memory, so it doesn't have enough heap space, so I'll have to adjust this. One thing's important to know: when you work with a Chinese corpus, you're going to have a lot of unique characters that make for a pretty sparse data set, which means that it's going to be very heavy on Mallet to try to run. So one thing you might consider is actually using that Corpus Dictionary to prune out things that don't occur very often. To do that, I'm just going to go ahead and reinsert this line, Corpus Dictionary, filter extremes, and I'm just going to say, you know, if it doesn't occur at least 5 times, then let's just get rid of it. So now, if I run this, it should work. And there we go, although you can see that the display is having some trouble here. But here we can see the results of the output. So you can see it's actually not that difficult to get this to work with Chinese. Something that I should point out is if you do run out of memory, you can actually go into Mallet and allocate it a little bit more memory than it has by default. So if you go into your file explorer, and you know I have mine in my root directory, if I go into Mallet, bin, and then if I right click on this Mallet file, and I open this with Visual Studio Code, there's a parameter called memory here that I can play around with. Here I've set it to 1 GB. You can set it to whatever you need, and this might take care of your problems. But with that, that is how you write a little script that does topic modeling for us. Now, in the next video, I'm going to show you how to visualize the results and actually interpret them a little bit. Okay? I hope to see you next time. Thank you.